Hello students, myself Anmol Jain, working with the IT department at AKGEC Engineering College. Today I am going to discuss the concept of the addressing mode. That is an important topic for the computer organization architecture subject. So let's start with the definition of the addressing mode. Addressing mode means to find the effective address, of an operand. Right? So the effective address of an operand can be found in different mode. That's why we are learning that what are the different addressing modes. So addressing modes, it specifies a rule for interpretation or modifying the address field. The objective is that how the address field is working differently for the different type of instruction, right? So before the operand is actually referenced, we have to see that which mode is applied here for the instruction. If the different addressing mode provides the different value of the address field, right? So variety of the addressing modes we are having. It gives the flexibility to the user. Why we are using the addressing mode? Why we are using? Because it gives the flexibility to the user for calculating the address of an operand in different modes. Next, it used to use the bits in the address field of the instruction efficiently. So there are different type of addressing mode. First is the implied addressing mode. In implied addressing mode, address of the operand are specified implicitly. Implicitly means the address is itself within the instruction. For example, if I say the effective address of the accumulator, if I say that there is a instruction INC, that is the increment accumulator. Increment accumulator, that is there is no address field is required here, right? Increment of accumulator means it is by default the contents of the accumulator will be incremented by 1. Similarly, suppose if I say the push operation, so there is no need to specify the address. There is no need to specify the address because the obviously the item will be inserted or deleted. That means either the push operation or the pop operation will be done with the top of the stack always, right? So there is implied within the instruction. Similarly, next we come to the immediate mode. In immediate mode, instead of specifying the address of the operand, operand itself is specified. That means we will not specify the address. We are not concerned finding the address because operand is itself there, right? So there is no need to specify address in the instruction because operand itself needs to be specified, right? Sometimes it requires more bits than address, but it is fast to acquire an operand. Next, we come to the register mode. Register mode means now we will hide the address within the register. That means we will find the address within a register. Address is hidden in the register. So address specified in the instruction is the register address. Address will be found within a register. So designated operand need to be in a register. Whatever the operand that need to be within a register. Operand कहाँ मिलेगा हमको? Register के अंदर. It requires the shorter address than memory address. Saving address field in the instruction, that is a benefit of the register mode, and it is faster to acquire an operand than memory addressing. So the effective address is calculated with the help of the instruction register, right? The address means the value will be found within the register, right? Because operand need to be specified in a register. This is a register direct mode because we will get the operand directly here within a register. Next is the register indirect mode. In contrast to the registered direct mode, in register indirect mode, now the register will contain the address of the operand, not the operand directly, right? So in register indirect mode, instruction specifies a register which will contain the memory address of the operand. Now the register is having the address again. It is not having the operand directly, right? So this is having two-step fetching of data. Once you have to go to the register, then see the address, what address in the register, then go to that address, that address means go to that memory address, then find the operand, right? So saving instruction bits register is shorter than the memory address. This is slower as compared to the register direct mode. Why it is slower? Because here we are searching or fetching the data in two steps. Once go to the register, see the register, what content it is. Actually, this is the address, memory address where the operand is. So basically, this is two-step address. Next is the auto increment and auto decrement. Again, this is a type of register indirect mode. So in this mode, we either increment the or decrement the value of the register. Next is the direct addressing mode. So here we generally confuse with the direct, register direct and direct addressing mode. So we should be very clear that we can have the address either memory address or we can have the address in registers, right? Either the memory address will be there or the register. So register related addressing modes are specified with the register, while memory related addressing modes does not use the term memory here, right? We have the register direct, register indirect, but we don't have the memory direct or memory indirect. So memory is being referenced with the name direct addressing mode or indirect addressing mode. If there is no term register, that means this is related with the memory, right? So in case of direct addressing mode, instruction specifies the memory address which can be used directly to the physical memory. That means direct addressing mode, instruction itself is containing the address. Instruction itself is containing the memory address basically, right? That is the address field of the instruction register. In case of indirect addressing mode, as the name suggests, this is indirect. Now indirect, the address field is not having the direct operand. The address field is having again address of the operand, right? So the address field of an instruction specifies the address of a memory location that contains the address of the operand, right? So this is slower as compared to the previous one, because again this is having two-step fetch of data or the two-step fetch of operand, because once you find the address, then again go to the next memory, then find the operand there. Next is the relative addressing mode. The address field of an instruction specifies the part of the address, right? That address field is having a small part of the address, and that we call as the abbreviated address, which can be used along with the designated register to calculate the address of the operand, and that designation register is known as the program counter. So to find the effective address in case of relative addressing mode, we add the value of the address field plus value of the program counter. So that will give you the relative addressing mode, address of the operand in case of relative addressing mode. Similarly, the index addressing mode, again the value of the instruction, value of the address in the instruction is added with the index register. Similarly, next the base register addressing mode, again the value of the instruction register address, whatever the address is given within the instruction, that will be added into the base register. So these are the different type of addressing modes. Let's see with the help of an example. Here we are having an example where we assume that there is an instruction that is of two address instruction. That is a two address instruction. Two address instruction means that an instruction is occupying two memory locations. So two memory locations are 200 and 201, and this is my complete instruction, and this instruction is having three parts. One is the load to accumulator, that is the instruction, then next is the mode, and third is the address field, right? So what I will do, that I will change the mode, and as or when I will change the mode, the address field will work in different type of mode. That means it will work like a as per the addressing mode which I will declare, right? So again I repeat, this is a two address instruction and occupying the memory location number 200 and 201. Apart from this, more information is given to us, that is the what is the value of the program counter at this time is 200. Additional register is given, that is having 400 value. Index register is given, that is having the 100, and the accumulator. These are given to you, right? And these are the different locations and content at that location that is given to you. And as per this problem, we have to calculate the effective address and the content in different addressing modes, right? So first I come to the number one, that is the direct addressing mode. So in case of direct addressing mode, what is the definition of the direct addressing mode? In direct addressing mode, instruction specifies the memory address. Instruction specifies the memory address which can be used directly to the physical memory. So if this is a direct addressing mode, then address field specifies the effective address, that is of the memory. So this will be my effective address. That means the operand will be available at this location. So what will be the what is the value of the operand? That means what will be the value of the operand that will be transferred to the accumulator. So go to this memory location, into this memory, and find the content or the operand. So at the location number 500, the value of the content is 800. So content to the accumulator is 800 here, right? So this is the definition of the direct addressing mode. That means the address field itself a address, right? Next we come to the immediate operand. So immediate operand means the content that is given in the address field, the content that is given into the address field is not actually the address field, this is the operand directly. It behaves like a operand. This is not the address now, the address field becomes the operand field in case of immediate operand, that means immediate addressing mode. So the content of the accumulator is 500, right? But suppose I say that what will be the effective address of this content? What will be the effective address? So where is this data? So this data is location number 201. So the effective address will be here 201, right? Next we come to the indirect address. So what is the meaning of the indirect address? So first you have to identify whether it is a register direct or register indirect, or it is related with the memory. So as the name suggests, there is no term of the register. If there is no term of the register, that means it is related with the memory related addressing mode. That means indirect addressing mode says that the address field is having an address, that is 500, but this is not the address of the operand. Indirect hai na? So this is not the value of the address of the operand. Again, actually this is the pointer to pointer. It will again suggesting that you will find the address at memory location 500. So the effective address becomes the 800. So this is my effective address, because this is indirect. If it would be direct, then this becomes the direct address field. I can find the value 800 as the operand, but no, in case of indirect, the effective address is 800, right? And what would be the content? What will be the content at 800? Memory location number 800, that is 300. So what will be the value of accumulator? That will be the 300. So this is an important one. Next, the relative addressing mode. So relative addressing mode, the definition says the relative addressing mode is the summation of two registers. One is the program counter value plus instruction register or the address of the instruction register. So the value of the instruction register is 500. This is the value of the instruction register. As per the instruction register, address value is 500. And what will be the value of the program counter? So this is to be noted now. This is an important concept, that what will be the value of the program counter. So the program counter always, it should be noted, program counter always contains the address of next instruction that is to be executed. So at this moment, this instruction has been fetched. Once the instruction has been fetched, the program counter is updated, because program counter always contains the address of the next instruction that is to be executed. So what is the address of the next instruction that is to be executed? That is 202. That means at this moment, the value of the program counter has been updated up to 202. Right? Once the value of the program counter has been updated, now the effective address in case of relative addressing mode, it will be program counter value plus address field of the instruction register. So the program counter value is 202 and the address field value of the instruction register is 500. That means effective address is 702. So the effective address will be the 702. And what is the content at 702? That is the operand value, that is the 325. So accumulator will having the value 325. So this is the definition of the relative addressing mode. Next, the indexed register. This is the easiest one, because we have to concentrate only the index register, that is my XR, plus the address field of the instruction register, that is 500. So it becomes the 600, because the effective address becomes the 100 plus 500, that is equals to 600. Right? So this is the effective address, and what is the value at the location number 600? That is 900. So the content will be 900 in case of indexed register. Now we come to the next, that is the register mode. Register mode means, so this is not specified, is a register direct or indirect. So we take this register direct. If it is indirect, it would be indicated register indirect. So this is a register direct. As per the definition, register itself contains the operand. Register itself contains the operand. So the what is the register R1 is having? That is the 400. So the value is 400. The value is, the content will be the 400. And what will be the address? There will be no address in the memory. You can say here that this the address will be the R1, because R1 is having the operand value directly, while in case of register indirect mode, R1 is having the address now. R1 is having the address of the operand. That means this is the address. This is the address of the operand. And what is the value at location number 400? This is 700. So the value at location number 400 will be 700. So the content of accumulator will be 700 if the mode value is changing. I am changing here, right? Next we come to the type of the register indirect, that is the auto increment or auto decrement. That means these are the types of the register indirect mode. So effective address in case of auto increment, that is 400, because increment is done post operation. Auto increment becomes the post, that is a R1 plus, this is a post increment, while in case of decrement, this is the pre operation. First decrement, then, and post increment, first increment, right? So here this is the 400, so there will be no change because this is a post operation, and in decrement this is decremented first. So the value of the rest in case of decrement, it becomes the -1 of this 400, that is the type of the register indirect mode. So that will be decremented by 1, and there will be no change in case of auto increment because it will increment post, right? So what is the value at 400? That is 700 again if it is auto increment. If it is auto decrement, the value will be 450 because at location number 399 the content is 450. So if once you are clear with the definition of the addressing modes, you should be able to compute the effective address and the content of the accumulator, right? Next one, again we take one more example, that is a 2-word instruction. So main thing is, this is again a 2-word instruction. 2-word instruction means it will occupy 2 memory locations in memory. A 2-word instruction is stored in a memory at an address designated by the symbol W. So if this is the instruction, this is W. If it is a 2-word instruction, that is next is W plus 1, right? The address field of the instruction. So what is the address field? The address field of the instruction is stored at W plus 1. So this is my address field. W plus 1 is my address field. Right? That is designated by the by. The value of the address field is by. That is given to you. Next, the operand used during the execution of the instruction is stored at an address symbolized by Z. See, operand is residing at location number Z. Operand is residing here. An index register contains the value X. That is given to you, that the index register is given to you value X. State how Z is calculated. How Z is calculated from the other addresses if the addressing mode of the instruction is number 1 direct. Number 1 is direct. So again we come to the definition of the direct addressing mode. So first identify whether memory related or this is a register related direct. So this is the memory related direct addressing mode because this is not having the term register attached with this. So in case of direct addressing mode, the definition is the address given within the instruction, the address field of the instruction itself become the address of the operand. That means in case of direct, the value of Z, that is the address, that will be the by because it is directly given. Now we come to the indirect. Indirect means now this by is not directly address. By is not the address. By is the address which is having the address. That means this is a by, this is having some location that will be having the address of Z. That means the content at here, will be having the address of Z. So how I will represent it? That the content at memory location by, that is the M bracket by, right? Next is the relative addressing mode. So what will be the value of the relative addressing mode? What will be the value of the relative addressing mode? As we discussed that the value of the relative addressing mode is calculated with the help of the value of the program counter plus address field of the instruction register. So what will be the value of the program counter now? So the value of the program counter is, that is the address of the next instruction. So what is the address of the next instruction? That is W plus 2. And what is the value of the instruction? What is the value of the address field in instruction? That is Y. That is W plus 2 plus Y. Next, what will be the value of, in case of indexed? Index means index register is given to you, that is X, that is the XR plus address field of the instruction register, right? So in case of indexed addressing mode, the XR is X is given to you, and the address field of the instruction, that is Y. So this will be your X plus Y. So in this way we can calculate the value of addressing, value of the effective address in different addressing modes, right? Next example, an instruction is stored at location 300. Instruction is located at address number 300, that means this is my 300, and its address field at location 301, and its address field is 301. So this is my address field. So what is the size of this instruction? This is a one address instruction or two address instruction. So again this is a two address instruction, because it is occupying two memory location, two address instruction, and the address field is having the value 400, that is given to you. A processor register R1, that is given to you, that is having value number 200. Now my objective is to evaluate the effective address if the addressing mode of the instruction is direct. If suppose the addressing mode is direct. So in case of direct addressing mode, address field directly contains the address of the operand. So address field contains directly the address of the operand. So this is what? This is the address. So in case of direct addressing, answer will be, effective address will be 400. In case of immediate, the address field becomes the operand field as per definition. In case of immediate, address field becomes the operand field. There is no need of the address field in the immediate, right? So what is the address? What is the address where the operand is? So this is the operand, that is 300. Oh, sorry, this is 400. This is the operand, and what is the address of this operand? That is 300. So effective address will be 300. Next is the relative addressing mode. Relative addressing mode, that is the program counter plus address field of the instruction register. So the program counter will be what? If this is 300, 301, what will be the value of the program counter now? That is the address of the next instruction that have been discussed with the definition of the program counter, address of the next instruction, that is 302, plus address field, that is 400. So it becomes the 702, right? Next is the register indirect. As per register indirect, register is having the address. Indirect hai. Indirect means register is having the address. So this is become the address. And index with register R1 as index register. In case of index register, R1 is also working as a index register. So the value of the index register is 200 and the address field of the instruction register is 400. So sum of this, that becomes the 600. So we can calculate the effective address in case of different addressing modes just by having the clear definition of the different addressing modes. Thank you. These examples are taken from basically the computer organization architecture by M. Morris Mano. That is a standard book for it. So I also advise to practice all the questions from the Morris Mano. Thank you.